Hi there students, and welcome to lesson 2 on the topic of quadratic equations and their graphs. In lesson 1 we established the fact that the graphs of quadratic equations, or the graph of any quadratic equation, will be a smooth curve called a parabola. And we established that for these smooth curves called parabolas, there are only two possible general shapes for those curves or for those graphs. Let's have a look at what I have on the board here. First of all, just a reminder of something we discussed in lesson 1, and that is that a quadratic equation is any equation of the following form. I've written it up here on the top of the board. Y equals ax squared plus bx plus c. And remember, ax squared means a multiplied by x squared. Bx means b multiplied by x. So that's just a reminder as to what a quadratic equation actually is. It's any equation of that form there. Y equals ax squared plus bx plus c, where x and y are the variables in the equation. A, b and c are fixed number values or constants. Now remember, a, b and c can be any number values at all, with this one exception. A, that is that value there, that constant there, a is not allowed to be 0. Reason for that is, if a was allowed to be 0, if a was equal to 0, then we'd have 0 multiplied by x squared, which is 0, which would mean that the equation would not contain x squared. If a was equal to 0, we'd have 0 multiplied by x squared, meaning the x squared term would disappear. Now, a quadratic equation must contain x squared. So, if a was equal to 0, then this equation here would not contain x squared, therefore it would not be a quadratic equation. So that's just a couple of reminders about things we discussed in lesson 1 on this topic of quadratic equations and their graphs. Now, continuing with lesson 2, we established of course last lesson that graphs of quadratic equations are smooth curves called parabolas, and there are only two possible shapes for these parabola graphs. The first possible shape occurs when a is greater than 0. A is greater than 0. So when the number directly in front of x squared in the quadratic equation is bigger than 0, that is, when the a value is positive, that's what bigger than 0 means, when the a value is positive, we get a curve like that. And that's called an upright parabola graph. So that's the first possible general shape for the graphs of quadratic equations. If the a value, in other words, if the number directly in front of x squared in the quadratic equation is positive, we get an upright parabola graph. Now, the second possible general shape for the graphs of quadratic equations occurs when the a value in the quadratic equation is less than 0. That is, when the a value is negative. And if the a value is negative, the sort of graph we get is this one here. That's called an inverted parabola. So these sorts of graphs are obtained when the a value in the quadratic equation is a negative number. I've written that there. A less than 0. A less than 0 means a is a negative number. Now, going back to upright parabola graphs, the very lowest point on an upright parabola graph is called the minimum turning point. So that point right there, that's the very lowest point. That's the very lowest point on this black parabola curve. That's called the minimum turning point. And another word for a turning point is a vertex. I've written that in brackets there. So that point there, the very lowest point on this upright parabola curve, is called a minimum turning point. And another word for a turning point is a vertex. Moving across to the second possible general shape for the graphs of quadratic equations, and that is an inverted parabola, like that there, that black curve there, that's an inverted parabola. The very highest point on that curve is called a maximum turning point. So that point right there, that point lies on this black parabola curve. It's the very highest point on the curve. That point there, I've written it on the board, is called a maximum turning point. Maximum means the highest, doesn't it? All right, so the maximum turning point is the very highest point on the inverted parabola curve. All right, so that's turning points. That's one key feature of parabola curves. Minimum turning point for an upright parabola, maximum turning point for an inverted parabola. Now, the second key feature of quadratic equation graphs, or the second key feature of parabola curves that I want to discuss this lesson, is the axis of symmetry. Now, an axis of symmetry is not part of the graph. An axis of symmetry is an imaginary straight line which can be drawn through a shape so that what's on one side of the imaginary straight line is the perfect mirror image of what's on the other side of the imaginary straight line. So an axis of symmetry, it's not part of the graph, it's an imaginary straight line. Let's come to the board and have a look at this upright parabola graph. Now, any parabola graph will have an axis of symmetry which is a vertical line. Okay, any parabola graph will have an axis of symmetry which is a vertical line going straight through the turning point. Vertical means straight up and down, doesn't it? So here's our parabola curve. There's the minimum turning point. The axis of symmetry, I've drawn a red dotted vertical line there. Okay, so that red dotted vertical line going straight through the turning point there, that's the axis of symmetry for this upright parabola. The red dotted vertical line here is not part of the graph. It's an imaginary line. It's the axis of symmetry. Now, an axis of symmetry can be thought of as being like a flat mirror. If you picture this red dotted vertical line as a flat mirror, if you put the left hand side of this parabola curve in front of the flat mirror, what you would see inside the mirror would be the right hand side of the parabola curve. So an axis of symmetry is an imaginary straight line which can be drawn through a shape so that what's on one side of the imaginary straight line is the perfect mirror image of what's on the other side. Let's move across to the inverted parabola here. Now, as I said a few minutes ago, any parabola graph will have an axis of symmetry which is an imaginary vertical line going straight through the turning point of the parabola. Here's the inverted parabola here. I've drawn a red dotted vertical line going straight through the turning point. That red dotted vertical line there, that is the axis of symmetry for this inverted parabola. And again, you can think of an axis of symmetry as being like a flat mirror. If you picture that red dotted vertical line as a flat mirror, if we put the left-hand side of the parabola in front of the flat mirror, or in front of the red dotted vertical line here, what we would see inside the mirror would be the right-hand side of the parabola curve. So an axis of symmetry, you can think of it as being like a flat mirror. What's on one side of the axis of symmetry is the perfect mirror image of what's on the other side of the axis of symmetry. Okay, that concludes lesson 2 on this topic of quadratic equations and their graphs. Thank you for watching. Watch out and stay tuned for subsequent lessons on this topic of quadratic equations and their graphs. Thanks for watching. See you next time.